So we have brought these lovely panelists here to talk about composability on Appchains, and I think we can start off with everyone introducing themselves. Just a quick, one-liner on what you're doing, name, and if you want to throw in a fun fact, you can do that too. Let's start here.
Does it have to be a one line?
You can do more than one line.
Hi everyone. My name is Paul Kim. I'm the CEO for XPLA or XPLA. It is a gaming and entertainment focused layer one. It was developed by one of the largest gaming companies from Korea called Come to Us. So one of the reasons why we're focusing on the gaming and entertainment ecosystem is because of our background. And so we have 25 years of experience in developing and publishing games. But over the years, we've invested quite heavily into the entertainment space in Korea. So we have access to billions of dollars worth of gaming and entertainment content and IPs. So what we wanted to do was leverage what we have, leverage what we are strong in, and trying to bring together, the gaming and entertainment contents over to blockchain and build an ecosystem around it. Right now, we're primarily focused on building our gaming ecosystem. We have 11 games on the chain so far. But really, what we're trying to do is become that bridge between the Web 2 world and the Web 3 world by converting the Web 2 gamers into Web 3. And we're doing that by both serving the Web 2 business, but at the same time enabling Web 3 features for our gamers. That is in a very frictionless and very convenient way for Web 2 gamers to convert into Web 3. That's a little bit about XPLA.
Awesome.
Hello, everyone. My name is JY Kim. I'm a co-founder and the COO of a team called Mitosis. And Mitosis is a unified liquidity layer for the modular era. Thank you very much for having me.
Hey, everyone. I'm Mikhi Pandey, and I'm the co-founder and CSO of Persistence. We are a Cosmos app chain that has been building in Cosmos since 2019, and we've worked around the problems of composability and a bunch of other things that you've seen in Cosmos. So very happy to be here and talk about composability, app chains, everything.
Hello, I'm Carter Feldman. I'm the founder and CEO of QED Protocol. So we are a zero-knowledge layer 2, fully trustless on Bitcoin. And we're building lots of really cool stuff. We built the first Bitcoin-focused IDE called BitIDE. And also a consortium of other Ethereum layer 2s that are now pivoting over to Bitcoin, the likes of which include Starkware, Mina, and a few others. So, yeah.
Hello, I'm Anil Kumar, co-founder, CEO of Rome Protocol. We are building a Solana-based shared sequencer for L2s and rollups, EVM-based rollups. This is to solve the problem of fragmented liquidity and composability that the rollup face, bringing them together. And I'm very happy to join this panel to discuss composability. Thank you.
And I'm Lacey Wisdom. I'm an investor at Protocol Labs. Protocol Labs is a research development and deployment studio and the creators behind IPFS, Filecoin, and libp2p, among other things, and we've been investing since 2017. So I'm going to start us off with a very existential question, and that question is, does composability matter for app chains? Whoever wants to go first can take it.
Yeah, maybe I can jump in. I think it's a very interesting question. The answer is it's context dependent, right? It's either a yes or a no in certain situations. Some app chains do need composability, some do not actually. It's better if they do not have that composability. I think also, especially building...
App chains need composability though, right?
I mean...
How do you get money into the app chain if it's not composable?
I mean,
it's just a new protocol.
No, I mean, it needs everything that needs composability. Yeah. We wouldn't even having this conversation if, it did
so
not...
isn't it just yes?
I mean, to a certain degree, right? Like, how much composability do you need? And, I mean, the whole point of this conversation is not just the part of money flowing in, but also going out, doing 10 other things with that money, right? It's not just about, oh, let the money come in.
So what's an app chain that doesn't need composability? Do you
I
have an
think,
example?
Like, let's be like Noble, for example, is a good one. The only composability that they need is IBC for that matter, right? Like IBC is inter-blockchain communication that connects multiple blockchains within Cosmos or beyond nowadays. But what does Noble do? It brings in USDC and allows every other chain in Cosmos to leverage the liquidity of USDC. What composability does Noble need?
So is IBC composability or no?
It is, but to that extent only, right? Like, do you want to go beyond that is the question, right? Like, how much composability?
How much composability do we need?
I mean,
we
I think-
definitely. So
I
the
think
answer is
that-
yes, and it's just a question of how much.
How much?
I think
Okay.
that might
Agreed.
be a good takeaway, right? Is like there's actually different levels to composability, and there's a question of how much you need, right? So would love to hear if there are other reactions too from others on the panel.
Yeah. Well, that was very interesting conversation you guys had. I think yes. My answer would be yes. I think it's also because our panel name is about composability too, and but I think we can divide it into two aspects in the user experience, and namely in the price discovery for DeFi across the different app chains. And the second part would be the developer experience. So just briefly going on to the price discovery. In the world that we are envisioning where app chains have this, they form this multi-chain ecosystem, there will be different protocols that have the same asset across different markets basically. But if they, on the opposite side where you don't have composability, then there will be price discrepancy across these different markets, and that ultimately could lead to bad user experience, and that could hinder the proliferation of the multi-chain and the app chain-based future that we are trying to envision and trying to build. So we think that on the price discovery perspective, composability, having a high level of composability and high level of interoperability is critical for app chains to thrive in the future. So that's the price discovery and then the UX part. Same for the developer experience too. I mean, the very ethos of the Cosmos was the Cosmos SDK, the fact that deployment and the operation of your new chain is basically very easy. They actually started the concept of modularity, and we think that being able to launch your own chain at a very with an easy way, and then at a relatively lower cost compared to just building a monolithic structure from the beginning, I think that really it acts as a catalyst for the proliferation of the more app chains coming out, more specialized app chains coming out, and then being interoperable with each other. So yeah, so that would be my answer.
I'd like to add 2 cents. So I think when an app chain becomes can you hear me? Yeah. Becomes independent in terms of its execution and supporting user, it is letting go of a certain aspect of being part of a bigger chain, which was composability. So now when we look at Appchain, it wants to sell its services or what it does to other chain. Other chain need to use these services, what that Appchain provides. So it need to provide some sort of composability to other chains to be able to be useful for the whole ecosystem. And to provide that, and there are different level of composability we can ask for, like messaging, IBC messaging, that is one. Someone might ask like, okay, maybe I can link transactions with ZK proof, or maybe I can provide atomic composability where your number of transactions are actually a single transaction itself. So that is a different level of composability. So you may have need for different type of composability, and you need to sell your services. And at the end of the day, the whole ecosystem is expanding because we want to make it easier for the user to use services. So this user experience has to be enhanced. When we create number of app chain, liquidity is fragmented, user experience is severely impacted. So we have to bring that back with the composability layer where we can provide the holistic experience to the user. We can cross-sell the services of each app chain to others. So we believe that composability is the one thing that every app chain should look into if they are going to expand their ecosystem.
So on QED, every user is a layer 3. And we can do that because the users prove their transactions. So every transaction on QED is only validated by one person, but it also comes along with a zero knowledge proof. So you don't have to trust the user for approving their transactions. We take the proofs, and there's this magic bullet of composability that we have nowadays, and it's called recursive zero knowledge proofs. And what that means is I can take a zero knowledge proof from, maybe it's the block proof for ZK Sync, and verify it in one of my users' transactions. I can verify ZK Sync, or Bitcoin for that matter, from Genesis in one of my users' transactions that's proved on their own computer. So we have this like holy grail kind of like magic bullet for composability, and we went perhaps even a little too much off the deep end and made composability everything. Like on QED, we don't have one set VM that you run. On QED, you set some zero-knowledge circuit which could recursively verify the ZK VM of your choice. Even a ZK VM that we don't know about could run on QED, right? So like, yeah, like we've spent a lot of time working on these problems. There are issues around synchronization. Like for instance, I can't interface with other users, like current state on chain. I can only see their state as it was at the end of the last finalized block. So there's this delay period that we have to maximize, but I mean, ultimately, I think the future of blockchain, even some of the bigger guys like Polygon with their super chain and a lot of this stuff is just like, are just sort of like us, like super bullish on composability. And for us, composability isn't like an amount that we want to like sort of figure out the right balance of. It's more like an aspiration. And we just try to like get as close as we can with the technology that we do.
I think that's a really good segue into talking about how each of your own individual projects integrates composability. So would love to hear from others on like how you're doing this.
So composability with gaming is probably less needed than other aspects of the blockchain. But the way that we're thinking about composability in gaming really boils down to the ability to, let's say you have an NFT, a gaming NFT, the ability to utilize that NFT across different games or across different mediums of entertainment. That's what so let's say you have a character, an NFT in an NFT form. If you're able to use that character for, let's say, a game like Summer's War, which is one of our RPG games. So if you have a character and if you could utilize that to play basketball on a basketball game, that would be interesting. Obviously, the abilities would be restricted by the game's boundaries, but the ability to take one asset and to use it across different games is something that we're exploring. The other thing is that for games, one of the most critical things about game is user retention and new user acquisition. So, but it's really difficult for games to maintain that for a longer period of time. What composability and interoperability allows is for games to tap into different communities on different networks and different ecosystems, and they can continue to acquire new users and sustain the lifetime value of the game for as long as possible. So those two things are the top two things that we think about when we talk about composability and interoperability within gaming. But beyond that, I think when it comes to DeFi, composability makes a lot more sense. Within gaming, it's really bound to those two aspects.
Yeah, and for us, it's more about like we're building in Cosmos, our objective is to build use cases around liquid stake tokens and in the future restake tokens, but purely from a Cosmos first perspective. So within Cosmos, the good thing is everything you build is standardized. Like every single thing you're building is built by, let's say, using the guides that you see on building a Cosmos SDK module. So every module you build, you're building it in a standardized manner that every other chain in Cosmos is going to use. That means you're by default composable with every other chain in some way or the other. Now, for us, like an example within Cosmos would be Osmosis. Osmosis has this LP token called GAM. It's a GAM module, GAMM module. This module, what it allows you to do is use the GAM tokens and do whatever you want to do. So any other chain tomorrow let's say, is Quasar, and Quasar is a chain in Cosmos that does vault management, LP management. They can take in the LP tokens from Osmosis, do exciting things. So Cosmos is unique in the sense that it provides that composability from the get-go because of the standardization of every single thing you're building. So it's quite important for us, and that's why we kind of focus on building everything in a way where, like, we have this liquid staking module, which allows people to liquid stake an asset. But it allows people to liquid stake any Cosmos asset as long as that Cosmos chain is composable with us, which means they should use the things that every other Cosmos chain is using. So that's kind of how we look at composability, and it's quite an important thing for us. Coming back to what Carter said, it's about how much composability you need. I do think for a liquid staking or a DeFi chain, you need a lot of composability, and that's kind of where we aspire to be as well, where everything we build is composable to the largest extent possible.
Yeah, I mean, so on QED, like our composability between different layer 2s, we actually made a consortium of various, like, very large layer 2s that are coming to Bitcoin. And one of our biggest sort of challenges that we wanted to solve is to make sure that users could transfer tokens from one Bitcoin layer 2 trustlessly to another Bitcoin layer 2 without having to have a transaction on the Bitcoin layer 1. Because Bitcoin transactions are expensive and we have very limited block space. And we constantly get flack from, like, the Luke Dash Juniors of the world telling us to keep our spam off their Bitcoin, right? Yeah, so, like, the way we do it is we maintain a Merkle tree on the indexer level on Bitcoin, and when people submit their block proofs, so they submit their block proofs in the form of ordinals, and one of the public inputs of that proof is their root state commitment, which for the most of us is the root of some Merkle tree, right? And then we build another Merkle tree where the leaves are the roots of each individual layer 2. And then every time we submit a block proof, one of our public inputs has to include a valid state root for that big Merkle tree. And what that means is that my chain, QED, is fully aware, trustlessly, of the state that's on Starkware, of the state that's on ZK Link, of the state that's on Mina. And that means that my users, as long as they have, let's say the token has a contract, one on Starkware and one on QED, the users can trustlessly bridge their funds to Starkware without having to do that Bitcoin transaction. So I think composability is easy if you don't care about security and you don't care about speed, right? So if you don't care about speed, you can just go back to layer 1 or just have like a hub and spoke model, right? Where everything is composable with everything else because we all connect to this one thing and then we send it to that thing and it gets really bogged down with lots of traffic, right? But then technically it's possible to move around, right? Ideally, we want to have some way, probably similar to the way we did at L2L, where there can be individual communication between peers in a network just so we don't have like the slowdown. And but yeah, I think JY made a great point. It's JY, right? Yeah. Like, we're in blockchain, we're in crypto. The most important thing for composability is that it makes you have more efficient markets, right? If it's easier for when there's a price spike in this place and funds can flood in, users get a better trading experience, markets are more stable, and it's better for the health of like decentralized finance as a whole. So I think that was a great point.
Anil?
Yes, so at Rome, composability is one of our key pillars of integrating rollup with the Solana ecosystem. So we provide a number of products within our suite that allows composability to the extent where you are able to atomically compose transaction from different rollups in a single Solana transaction, or for that matter, taking a Solana transaction and compose it atomically with a rollup transaction. So that means is your transaction get executed as a single Solana transaction. So that is the strongest form of trustless, non-custodial composability that you can get on a blockchain because your transaction is just a single transaction across number of rollup and Solana ecosystem. So we have a product, ROM SDK, that builders can use to compose these transactions, or they can use Remus for cross rollup transaction or Romulus for cross-chain transaction between Solana and rollup. So in terms of composability, atomic composability, so we provide a number of solutions for the builders and the community to make use of and create composable transactions.
And I feel like Jack started to touch on Carter. So bad with names. I feel like you started to touch on some of the trade-offs that come with composability. So would love to just have like an open discussion about that and like maybe talk about some of the primary risks that you see coming from having more composable solutions and some of the things that we need to kind of work on to make composable solutions work in Web3.
Everything is already composable except for Web3. Okay? Like everyone has APIs, everyone has already solved this problem. We just need to change our habits, right? We can't use serial state machines. We need to adopt zero-knowledge proofs so that the like trustlessness of one thing can be extended to another without everyone having to run like a node of every single blockchain in order to have IBC, right? We need to change our habits. We need to upgrade our technology. And in the short term, I think composable blockchains like ours may suffer a little bit on developer adoption from existing blockchain circles. But I'm also confident that the Web2 folks that are already used to writing these kinds of things that people are meant to use, you know, it should be relatively easy for them. So yeah, as an industry, I think we're moving towards there. That's why you see the big players in the game all talking about super chains and these kinds of things, because like this is the only way that we can justify the amount of capital that's been invested in blockchain is if we start to have some normal people use us, right? Like if we keep doing this, it can't go on forever, right? How many people use blockchain? Not that much. We need composability to scale up, and you know, if you have scale without composability, it means you have islands. I have 1,000 Ethereums, and I can only transact with a cohort of 20 people, right? That's no good. So we have to have composability with minimized trust or trustlessness. And there doesn't have to be a trade-off.
Yeah. I think someone on an earlier panel said that each blockchain is like its own little city full of its own citizens right now, and we're really right now, I think you used that term islands, we're all
some of them smaller than others,
on our
right?
own L1 islands, some of them very tiny. But yeah, Anil, I think you were going to say something?
I think in terms of risk is not doing enough for composability as opposed to doing composability. I think that's a risk that some of the application that we see, whether it is a cross-chain lending application that require composability, whether it is a real-world asset or tokenization of a real-world asset, let alone the arbitrage and DeFi application where you need composability. I think this composability is very much needed. If we are not solving this problem and waiting for some real blockchain that can actually provide composability at a very grassroots level, I think that would be something that we need to be wary of. Like some people talk about the ZK proof is years away in terms of speed at which it is needed. So I was talking to my friend over here and I said,
80 milliseconds. Fast enough or not fast enough to prove a transaction on your iPhone? Fast enough?
I have to see the proof though, but I'll take his word for now.
I'd love to give you a proof of math, as our shirt says, right?
So that's where I see that not doing enough is the risk rather than doing too much for composability.
I think a point that Carter you mentioned, which is I think absolutely spot on. It's having composability, but in a trust minimized or trustless manner. Otherwise, you know, you have composability, but at what cost? Because it's not trust minimized, it's not trustless. There are huge risks with that. I think in general, composability comes with the contagion risk, right? Like something blows up, everything can blow up with it. But that's the cost of kind of doing it in the, I mean, if you don't do it in the right way. If you do it in the right way, then you don't have to worry about contagion risks at all. And you can create situations where your app chain, for example, is protected from that contagion in a big way, right? Like Cosmos chains have this thing called IBC rate limiting. You can rate limit the amount of assets that come onto your chain on a daily basis. Now, if something blows up, you're still protected in some way or the other. So you have to take these small risk mitigation efforts or you know, practices that you choose for your particular app chain or your particular use case to avoid a situation like that. But you know, it does come with risks.
So, well, actually, I would argue that every chain needs composability, and the ones that aren't designed to be composable tend to have people shoehorn the composability on top of it, which usually leads to disasters. You usually go from a situation where, like, you have, let's say, I don't know, some DEX that's interacting with a smart contract, right? And suddenly, the smart contract has been exploited by the token that it interacted with, right? Like, if we set up these barriers from day one with the chain, then we can much, I guess, more clearly model it from like a security or attack surface perspective. But if we just try to add it on later, it usually leads to problems. Versus like, if I just in the protocol define like what the I guess exploitation cases are for some smart contract, or what like interactions. For instance, let's just disable reentrancy. Why do we need reentrancy, right? This shouldn't exist. But Ethereum wasn't designed with a very mature grasp of composability, since there wasn't composability on blockchains at the time, so fair enough to them. But like the chains that do have composability built in, like Mina has, you haven't really heard a lot of exploits going on Mina, right? A lot of these chains, you know, they're doing a pretty good job of it. But yeah, like the more you design for it, because it's going to happen whether you like it or not, is what I'm trying to say. People are going to do it. Otherwise, they're just not going to use your product.
Yeah, I think it's a good point that things that are more composable have a much larger attack surface. And so how do you design things with composability in mind, like making sure that the security is there so that like you won't have exploits from integrations with like all these different kind of execution layers?
I think you can design things in a way where, let's say, you know, for example, we do liquid staking. For us, what matters is if we want to get integrated into a money market, into a borrowing lending protocol, they are going to need our exchange rate, because the liquid stake token, its value appreciates against the native token on a epoch basis, whatever that epoch could be. For us, it's a daily epoch. Now, the money market will have an oracle that's going to feed the price of the liquid stake token to it. But the money market is also smart enough to take another input, which is the actual exchange rate of the liquid stake token and the price of the underlying asset. Now, what happens is if we build one module which does everything, which does liquid staking for 10 chains and provides this exchange rate to every other chain in Cosmos, you're kind of creating a situation where if there is one small issue with the exchange rate providing, you know, aspect of the module, it's going to mess up everything. So you kind of build things in a composable way to avoid risks that could take down everything. So what we've done is we've built a different module that fetches this exchange rate and provides it to every other chain in Cosmos, for example. So you build from a composability first perspective to kind of avoid the contagion risks as well.
Well, so I think the solution is isolation. Like, if I call, well, let me put it like this.
Isolation was the problem.
No. You just have isolation with a very clearly defined window, so I can signal out the window to you. Like, okay, let's say I'm using the Stripe API, right? Because I called the Stripe API, that doesn't mean that Stripe can like go into my internal VPN server and talk to my internal services, right? It can't then go and call up, I don't know, my Twilio account, right? Like, it's okay for applications to be isolated and have a clearly defined interface for communicating. And in fact, this process for free also gives you horizontal scalability, because you have hard guarantees against race conditions, right? I mean, the only other way to solve this problem is, I don't know about any other ways, but for serial blockchains where we do allow this reentrancy, these kinds of patterns, there's only one answer, to be honest, which is CVC3, right? You can use formal verification to try, but if you don't write your FV queries very clearly and you don't define the constraints clearly, you're just as screwed as you were without formal verification. So, yeah, that's at least my 2 cents.
Awesome. And JY, I feel like you had a thought, so I want to let you have room to air it.
No, I think we're running out of time. If any of you guys are interested in what mitosis is and interested in what we're building, I'll be around, so please don't hesitate to reach out, and then yeah, we'll have a chat. Thank you.
Awesome. Well, thank you all for coming here today, and thank you to Dora Hacks and all the other sponsors for having us.
Thanks so much, guys.
Thank you.